Hey there, folks. Welcome back. Unit 4, we are talking about geospatial data and database management. So this unit, we will be introducing different data types, measurement scales, and data capture methods. We'll ascertain the different types of errors inherent in geospatial data sets, hopefully provide an overview of the most common types of vector, raster, and hybrid geospatial data file formats, understand the basic properties of a relational database management system, outline the basics of the SQL language and understand the various query techniques available in GIS, and create and configure layers in ArcGIS Online. For your homework this week, you will be reading Chapter 5 in your text. You've also got your Unit 4 quiz, and you are doing your labs 3-1 and 3-2 in your lab manual. All of that is due Sunday, February 16th at 11:30 p.m. Let me know if these deadlines are not working for you and we can work something out. Let's jump in. We'll talk a little bit about geospatial data management. So this unit, we're going to look at how geospatial data gets organized, stored, and processed within GIS. So first, you'll learn the two main data types, vector, which is points, lines, and polygons, and raster, which are grids of cells for continuous data. Each comes with its own strengths. Vectors are great for precision, while rasters are really great at showing gradual changes across space. We'll also check out different ways to store data, from simple flat files to databases. Relational databases let us link different tables of information, making them really handy for large, complex data sets. And we'll also discuss SQL, that's structured query language, which is a common tool for querying and manipulating data that we're not actually going to be applying in this course, but is something that I want you guys to be aware of as you move forward with your careers in GIS. So next, we'll talk about spatial indexing, which is a key topic as it organizes data in a way that allows quick retrieval. Especially, this is important when dealing with really huge data sets. So techniques like quad tree and R tree indexing can dramatically speed up spatial queries. These are not really, again, going to be things that we run into in this class, depending on what you pick for your final project. But as you move on to apply these skills in your professional or academic lives, you might run into some really enormous data sets that are going to require these skills, or at least make your life a lot easier if you're familiar with these skills. Moving on, because GIS projects often pull data from various places, we'll look at common challenges with data integration, like handling different coordinate systems. This is something I'm actually kind of a nerd about, really enjoy the integration of different coordinate systems, and also file formats. So you'll learn practical solutions like reprojecting or converting data and best practices to ensure your changes don't introduce errors. Lastly, we'll showcase real-world examples where vector and raster data come together in one project, such as analyzing environmental impacts on a city's infrastructure. The unit's going to wrap up with some tips for file naming, you know me, metadata maintenance, and regular backups, which will all help keep your data accessible and trustworthy as you work through your projects. All right, let's talk a little bit about your labs. This week in lab, we are going to be creating layers. As you create your own layers, you are also going to configure item details and settings of those layers. My big tip for you this week is that this lab is going to take a little bit longer, so I want to make sure you guys leave yourselves plenty of time. The other tip that I want to offer for you is to take advantage of the on your own highlighted boxes in your lab manual. These activities are really enriching and are going to help you understand this tool a lot better, which is not necessary for you to get through these labs and just check the boxes. But as you get to your final project, and certainly as you move on past this course to apply these skills in your professional life, you're definitely going to want to take the time to go through those highlighted on your own boxes in your lab manual. Cool. So before I sign off, fun mapping website of the week is worldmapper.org. This is an interactive site that it reimagines the world through cartograms, which are maps where the size of each country changes based on different data, like population, income, resource use, lots of different metrics that are applied on this website. So it's kind of a twist on a typical map where instead of seeing each country projected, consistent with a model, these are all going to be distorted. So let's say you had a map that was showing the size of countries based on population, right? China's still a big country. India's even bigger. The United States is still a big country. Indonesia's a huge country. But a country like Canada, which we all know is geographically enormous, is going to appear really small on the map because there are only about 30 million people. So it's a really interesting way to convey information. It's a fun way to shape your worldview and develop a better understanding about the world around you. The website is worldmapper.org. I'll post it in the unit description. As always, hope to see you guys in office hours, 5:30 to 6:30, Tuesdays and Thursdays. If you can't make it, shoot me an email. Hope you're having a great week. See you soon. Bye.